Hello, fourth graders. All right, today is Thursday, the 15th. We wore our purple today to support our military box run kiddos and their families today. And then, let's see, let me get my book out here. All right, so today we started in 15.2. It's a new section where we actually started working on conversions. So we started on page 526. And right here. All right, so we first started talking about when we're moving larger units to smaller units. And so in this case, we were using tables to show examples of how we can help organize our information. And when you're moving from a larger unit to a smaller unit, we're using multiplication. So we made a note up here. So it says Emma has 4 feet of thread to make some bracelets. How many inches of thread does Emma need? So the first thing, you need to identify what the units are that you're using. So here we're using feet and we're using inches. Then we need to go to, we wrote this down in our notebook, your reference, and it's also in your reference materials. So this is what we put into our notebook. So go to the one that has length. And here we're talking about feet and inches. And so the conversion is that 1 foot is the same as 12 inches. So then we need to think about, okay, this is a bigger unit to a small unit because a foot is bigger than an inch. And so because we're doing that, we're going to use multiplication to help us out. So we know that 1 foot is equal to 12 inches. So we're multiplying that 1 foot by 12 to get those 12 inches. If we had 2 feet, we would multiply that by 12 and get 24. 3 multiplied by 12, we get 36. 4, and then 5, and so on. And so we built this table by applying that rule of multiply by 12. And we were able to find out that if she has 4 feet of thread, she's going to also, or it's the same as having 48 inches of thread. So on this next example that we did, this one here is examples of moving from a smaller unit to a larger unit. And so with this one, we're doing the opposite. So we're using division. And so it says Jason ran 300 feet during recess. How many yards did Jason run? So here we're using feet and we're using yards. So we had identified the 2 units. We went and we found the conversion. So we said that 1 yard is equal to 3 feet. Here we used a table again to show that we're taking those 120 feet. Well, here they just gave us some different feet. So here we use that rule of dividing by 3. And so when we got to 300, we had divided that by 3 and we got 100. So if he ran 300 feet, that's the same as running the 100 yards. So pause that, make sure you get that. Then we went over to page 527. And we started talking about using it, instead of using it in a table, we were thinking about it with the strip diagrams. So here, this was showing 1 yard, and we know that 1 yard is equal to 3 feet. So each one of these boxes was the same as having 1 foot for each of them. So we know that a yard is 3 times as long as 1 foot. And so we use this information to help us with some of these. So we said, okay, we could take it even further and we could say 12 inches is equal to 1 foot. So if we had 2 feet, that would be the same as 12 and 12, which would be 24. Then we thought about, okay, if we've got 7 yards, we know that 1 yard is equal to 3 feet. And here I'm going from a larger unit to a smaller unit. So I'm going to use multiplication. So 7 times 3, take that 3 there, multiply it since we're going from a big to small unit, and I get 21 feet. Over here, we're going from a small unit to a big unit. We're going to use division. 144, take those inches. We know that there's 12 inches in 1 foot, so we're going to take that 12 and divide it and get 144 divided by 12 is 12. And we were using what we know with multiplication, so we were thinking backwards. So we were thinking, okay, we know 3 times 7, or I mean, 3 times 7 is 21, so that was just straight. But here, we were thinking 12 times 12 is 144, so that helped us to be able to solve that one there. Then all of this, once you go to your seesaw, oh, here, let me get out of this. Save that. All right, so in Seesaw, in your activities, week 31 math, go down to Thursday. Your assignment for today is on page 529. You have 1 through 9, and you're going to upload the work that you showed here. And your work that you're uploading, you're making these conversions. So I'd really like to see where, if you had 12 feet is equal to how many yards, I'd really like you to show, okay, blank yards is equal to blank feet. I'm going from a big to a small unit or a small unit to a big unit, so therefore I need to either multiply or divide. I'd like to see you write all that out, so you can help set yourself up for success. So when you jot that information down that you need, that's going to help you solve your problem correctly. When you are done with that, ST Math is what I'd like you to remember. We're trying to get 15 minutes a day. I checked the list today. Some of us, we've had Monday, Tuesday, Wednesday, Thursday, where I've been saying, okay, 15 minutes, 15 minutes, 15 minutes. And some of you for the week are still at 0. So make sure you're getting on that and practicing. Then for reading, we read what did we read? Chapter 9? Yep, chapter 9. So we read chapter 9 in Fudgemania, and that is under your book club here, tab in Google Classroom. So you've got chapters 1 through 9 now. And then we went to Seesaw for our activities, and we've got book study Fudgemania. Find that. Yesterday we went over the character chart. What happened? Try that again. All right, so yesterday we did the character chart and made some predictions. Today we talked about kind of the sequence, going back in just the sequence of events that we've been working on, or that we've been reading about. So we started with the exposition, which introduces the setting, where the story is taking place, who are the characters, just some information about your characters. So we put that here on the bottom. And then our rising action, we started talking and going through the chapters and talking about the big things that happen throughout. And we can organize it on this plot mountain. And then we can also put it on something like a timeline. So the same information, we just copied it over and said, okay, here's, this is another way we could represent that information as having, here's the beginning of the story. And as it's going down, these are the events that are happening as the story is moving along. So we did that, and then we drafted that. And then for independent work, so all of that we did together. In independent work, students started on Fudgemania Section 3. And here, all right, Section 3, we've read today Chapter 9, so we can start working on this. The first part is Dictionary Detective. So you're using a dictionary, if you have a paper copy, or just dictionary.com to find the definitions for the words there. On page 3, you are finding synonyms. So synonyms are words that mean the same. So looking at these words, what's something in this box here that means the same as that? Or I'm sorry, looking at these, which one matches there? And then here you're taking what you understand about what that word means and applying it to the correct sentence. So that was the goal to get through today for independent work. And then tomorrow we're going to wrap up just some understanding the story, talking about some comprehension questions that we understand after reading. And so go ahead and draft that. We'll finish the rest of that tomorrow and turn that in. And then going down for writing, we did our daily writing review on page 7, and then our quick write was to tell me about a goal that you have and how you're going to make it happen. So if you go to Google Classroom, right here, daily writing review, you can click on this. And page 7. So you have your anchor chart here. So we talked about these 4 types of sentences again, and we went over here. And then when we were finding plural words, we did some dictionary practice again where, if you look up the word foot, it's going to, down at the bottom of the definition, it's going to show you where, or not where, but what that plural noun is. And so you can use the if you're stuck and you're like, I'm not sure what that that would be. If I have more than 1 foot, go ahead, use the dictionary. It's a great tool to help you with those ones that have changes in spelling. It's right there. Look up that singular word, and then look down below at the end of the definition, and it'll say on there plural. Then here we were revising this sentence. We were talking about how we needed a subject, that this was just an incomplete thought. And then these last 2 had to do with combining sentences. And so we talked about, we don't always have to combine sentences using the comma and the fanboy. Sometimes those 2 different sentences, they sound a little repetitive. If I were to say, like here on A, earthworms have 10 hearts, comma, and earthworms are slimy. That sentence is correct. That's fine to write it that way. But it would be better, instead of saying earthworms, if instead we said earthworms have 10 hearts and are slimy, then I don't have so much repetition. So even though A is correct, C is stronger because it doesn't have that repetition. Your quick write today is on page 8. Tell me about a goal you have and how you're going to make it happen. So a goal is, something that you're trying to accomplish. What is it? And then not just what is it, but, what are you going to do to make sure that this happens? So maybe your goal is to go off into space someday. What are the steps? Like, what can you do now to make sure that you are, headed towards reaching that goal? All right, for science, we finished up our lab, so this is going to be where that starts. So let me start this.
Hello.
Let me fast forward a little bit. All right. So let me see this so y'all can see here. All right. Yep. All right, there we go. Okay, so here is the gravel water. So we're going to measure. So here's our cylinder.
And we're going to pour the gravel water in. So this is everything that drained. Once it went through the gravel, this is what drained. And so we're going to add this to our notebook. So in your notebook, title it Soil Lab Notes. Yes. This one's counting by tens. So soil lab notes. And our first one is gravel. So if we look at it, if it's counting by tens here, it's right at 90. Spare slow. What are you doing? We're doing science. I don't know what you're doing. So 90 milliliters drained. So if we started off with 100 and we take 100 milliliters minus 90 milliliters, how much was retained? How much stayed with the gravel?
10.
Okay, so you subtract those and you get 10 milliliters retained. Okay, so that was the gravel. Then next we had sand. So let me pour out the gravel water. All right, so let me stop sharing here. All right, so next, can y'all see the cylinder at home? All right, so there it is. All right, so sand is next. So I'm going to pour the water in so we can measure how much we have of it. Get it all in there. All right, if you were late joining, we're measuring our water of what we measured or what drained out. All right, so it is just right under the 90 mark, kind of close. Let's just say it's right under. Let's just do 85 because it's kind of right under in between there. So if you have sand, if you have 85 milliliters drained, how are we going to find out how much was retained?
By subtracting.
Subtracting.
So we're going to take that total, subtract what drained out, and what does that leave us with?
15.
15 milliliters drained. Okay. Next, we've got clay. So let me pour out the sand water. All right, for clay has very little here. Let's see what's going on with the clay.
Oh yeah, I remember the clay didn't drain very much, like barely any.
All right, so here's clay. And she's a little bit on, can y'all see a little bit on the bottom here? So clay is right at, if this is 50, what would the clay be?
30.
Let me see. Well, let me get it. I'm trying to hold it in the air and it's rocking back and forth. Let me get it settled.
All right, I'm going to pause this because I've got to go to dismissal. And I'll come and finish this in a second here. All right, let's continue where we were.
Looks like it was 30, but also kind of 40.
Well, hold on.
I'm late because the alarm didn't go off.
What was it, Chris? 30. Okay, so All right, Spiro says 30 and Lila says 30. Let's go with that.
Okay.
Landon, if y'all I said if y'all joined in late, we're going over the what was that, Clay? We're going over the measurements of what drained out. So Clay was, what'd y'all say, 30?
Yeah.
All right, so 30 milliliters drained out. So let me call on somebody. Angel Perales, how am I going to find out how much retained? Oops, I wrote the wrong word here. This is supposed to be retained.
You do 100 minus 30.
Okay, so we're taking what we started with minus what drained, and what we're left with would be what?
70 milliliters retained.
All right, 70 milliliters retained. So that means quite a bit, almost all of that water the soil held on to. Gracie, we're not eating, lunch is over. We just had almost an hour to eat. Please get out your science notebook and make sure you're following along. All of this is getting uploaded. Make sure you're following along, please. All right, last one, we had topsoil here. All right. Yep. All right, topsoil.
You should also have moss.
Moss, I don't have, because we were just looking, I told y'all moss is not a soil. Moss is, we were just looking at what it does with the water when you put water on it. And we're going to talk about moss at the end. I'll tell you what I want to do with the moss. All right, it's right. What do you think, Annalie? 55?
Yeah.
All right. So, all right, thank you, girls. All right, go write that down. All right, so topsoil was 55 milliliters. So let's see, Jonah, if I wanted to find out how much was retained, what would I say?
Say that again. Sorry.
I want to know how much water retained with topsoil.
The topsoil you could retain.
Make sure you're following along. We just did 3 examples. Carter, how am I going to find out how much is retained?
How you are going to find out how much is retained is why is everything so big? Maybe you may not really sure.
All right, someone help him out. Mustafa, what are we going to do?
I know. 100 minus 55.
All right, so everybody, if you weren't sure, look here. We take what we started with. So we started with 100 milliliters. We're going to take away what drained out. That's the part that we could see that came out. And what's left is the amount that was retained. So we have to take what we started with, take what came out, that missing piece, that piece that's with the water. If we subtract it, we find that missing part. So 100 minus 55 is?
45.
45 milliliters. Okay. So now let's look at the, draw a quick little chart down here. We've got gravel, sand, clay, and topsoil. Put the amount that was retained. So we've got 10 for gravel, 15 for sand, clay 70, and 45 topsoil. And these are all, we're talking about milliliters. What does all that information, how does that connect back to the particle sizes?
It's talking about like how big or small they are. For like the gravel, they were pretty big sizes, so not a lot stayed in with them. And then the sand, you could still, they were tiny, but you could like still see the individual parts. So that's why a little bit more was there. And then you could really see the clay parts a lot, like, but they were, like, you could see it, but like you couldn't see like every individual one. So that's why a lot stayed in with that, so we wouldn't plant our plant with the clay, but 45 is like the best because it's not too much and it's not too.
Okay, thank you, ma'am. Very well said. So our things that had really big particle sizes, look how small their numbers are. So these are the ones, these right here, the gravel and the sand, these are the ones with the big particle sizes. Clay has a very small, this is your smallest particle size. Look how big the amount that was retained. And then topsoil, what do you notice about it? What do we say about topsoil? Yeah, it's kind of in the middle where, yes, it's holding on to some of the water. It's also, yeah, it's retaining. Retaining means hold on. So it's holding on and retaining some of its water, but not all of it. It's letting some of it drain through, which is what we said we like and we want, because we talked about those extremes. Too much water is bad, not enough water is bad. We want that in between, okay? So I'll give you about a minute to get all that. Make sure, well, hold on, let me let you catch up. Anybody need more time?
Is this why they like? Is that why they like? If you are going to plant something in something, unless it's like going to be decorative, that's why it's always like. That's why they always have like topsoil or like soil there, because that's the best one.
Yep. But it also depends on the plant. There's some plants, like when I lived in Houston. And I had a flower garden in the front of my yard, and if I dug down into the soil, it was like a reddish color, and so I could tell if it's red what kind of soil did.
Okay, so that just goes. I continue with this story about how I had clay soil, and I had some azaleas that did really, really well in the clay soil. So I was given an example about how different types of plants and flowers and things like that can do better in one type of soil versus another, depending on its needs. All right, so we took that information, those notes from the lab that we did today, and we went to Seesaw for our week 31 science assignment here, and we opened this up. And we added a page. So yesterday we started the lab notes, and we took these. Click on this and hit Control-C to copy, add a new page, and then so you now have a second page that says hit Control-V, and you can, or just type lab notes here. So our lab notes continued on this next page. So these were the notes that we took. Go ahead and upload it to this. And then the last part, we went ahead and we planted our seeds, and we're going to talk tomorrow more about the ability to support plant life. So We know these different things about these different soils, so we're going to be watching and observing them. And so tomorrow we'll make some predictions about which one we think is going to be the best support for life. So go ahead, draft that, and we'll finish that tomorrow. Then, all right. We had library after that, and then for social studies, we were talking about, where is it? Here, social studies. All right, so click on your week 31, and you can read about traveling to the moon and all about NASA. And Thursday's page, the article is right here, Texas leads the space race. So what happened on July 20th, 1969, and then what is one of the jobs of NASA? And so go ahead and fill in that. And then there is a video. I clicked on the wrong one yesterday by accident. So we already watched it yesterday, but if you missed it, go ahead and watch this video about Neil Armstrong, and then you can look at some more facts about that there on this document here. And then at the end of the day, let me take this off. We actually did. All right, so we were practicing division at the end of the day and talking about the job of a remainder. So let me make sure that we've got everything. The small group point of view, I'm going to take this off. We finished this. This can be turned in. And then that was it. All right, so tomorrow is Friday. We'll wrap up all of our assignments that we've been working on for the week and have everything turned in. So if you're missing anything from Monday to Thursday, please go back, look at the agenda, make sure that you have everything completed. I still have some things like the CFA and some things that we did at the beginning of the week that are still missing. So please, please, please go back and double check through the agenda, every single subject, and make sure that you are all caught up and ready to go to turn in everything by tomorrow. Alrighty, guys, have a wonderful evening, and I will see you on Friday. Bye.